Hello there, this is Professor Meiskens, and I'm going to give you a quick tour of the lab, and we're going to work through the lab today for lab 2, the freezing point depression, and in the process you'll be able to write down some of the data that you need for this lab. So what we have in our lab here is, as I showed in the intro video, we have our two balances. We have our lauric acid, and we have a test tube here we're going to measure the lauric acid into with its plastic support for the balance. We have a little bit of unknown A to add a little bit later. We have over here a hot plate with water, and the temperature is a little bit in the high 60s. I'm going to turn it down just a titch. We don't need it any warmer than that. We have here a stirrer and a clamp with a temperature sensor. And here we have Logger Pro ready to record our freezing curve. So the first task here is to measure out about 4 grams of lauric acid. So, as I showed before, I am going to grab a wing boat, and I put that on my balance. And I'm going to hit the button that says tare. Each balance can be a little bit different. We want to zero it. Last time I had a little trouble with large chunks, and this is the easiest way. I don't need a spatula. I'm going to get close to 4 grams. So I learned from last time I have to be careful not to get big chunks out. I'm at 3.3, and I'm just kind of tapping to. All right, it says 4.07. I don't need to write that down, because what I care about is what I end up delivering to my test tube. So we're going over to the analytical balance. Here we go. I have my test tube and my support. It's going inside my balance. And I'm going to press this bar after I let it kind of settle. Press the bar, and that makes it 0. I'm going to press it again. It's reading 0.2 milligrams. Okay, so we're reading 0. I have one big chunk that worries me about getting that in the test tube. And if we get that one in, there it is. Okay, I didn't spill any into my plastic container. So now the mass that I read here is going to be exactly the mass that we need for our reading. So there it is. If you need a little more, you could pause your video. 4.095, sorry, 4.0594. So we have just a titch over 4 grams, and that's perfect. So we're going to bring this over here. Next thing we want to do is we want to melt it. So here we go. So my temperature here is a little bit over 70. I don't need it to be much warmer than 60. So I'm going to turn it down a little bit. And I can already see it starting to melt. And if I keep it moving around, that keeps some fresh hot liquid on the edges. And it also means we can kind of move the solid around inside it. And I don't need my thermometer here the whole time. I can set that out. And that allows me to kind of swirl. And what we want to do is we just want to melt it sort of as soon as possible. The longer it takes to melt, the longer the experiment takes. So I'm just going to keep moving this around to try to make it melt as quickly as possible. And I can show you that we are partly melted. And then we're going to put it over on our Logger Pro. Our Logger Pro is set up so that as long as they have the temperature above 50 degrees and we click collect, then it will start collecting data as soon as the temperature drops below 50 degrees. And so I'm just swirling it now. Now there's at least 2 people at each bench when we have the class full of people, and so it could be that one person has to wait, or it's also possible to sit this in the bath and just let it go. I still have a little chunk of solid in here. What I'm doing right now is I have it on my stirrer, and that also helps get it to dissolve and become liquid. So we now have completely melted, and I'm taking my thermometer and I'm putting it in, and I want to make sure my thermometer is in the center and it's a little bit above the magnetic stir bar. And now our temperature is 51 degrees. Here's our screen. It says 51 degrees. And I'm going to collect. And now it's starting to cool from 53 degrees. So it won't start recording data until it drops below 50. And it takes about 2 minutes really to get from 50 down to where we see a phase transition. So it doesn't take terribly long. Now the higher I go above 50, the more cooling has to take place before we start even recording data. So I can take this off the stand and move a little closer. There's our temperature. We're now below 51, and oh, here we go. I'm going to move this, moving the stirrer so that the test tube is in the very center, and that really quiets it down quite a bit. And if we look over here, we can see, oh, we're at 49.16, and you can see that we're starting to record data here. So I'm going to stick you back in the stand. We are getting our temperature now. Started at 50 and it's coming down. And it won't get a phase transition until it gets much closer to 40. So it takes about 2 minutes. And we've not even gone a whole minute yet. So it's cooling. It's cooling just because it's sitting in the lab air and not in a hot bath. So the temperature keeps coming down. We're down to 45 degrees. And it keeps coming down, and we're watching for an inflection point, a place where we will see the start of the freezing. And I'm going to pop this out of the stand again. We'll bring this over a little closer look. Here's now 43 degrees. And if we come over here, we can see a little further. There we go. We're still completely liquid. There's our camera right on there. And we are seeing some solid now. So you see solid floating around in the solution, and we can see now that we have a dip in our data. So at about 43, we're close to our freezing point. Let me put you back in the stand, this time without stopping the video. And so we dropped down. We had a low point, it popped back up, and that little droop below this point here is our supercooling, where it dropped below the freezing point, and then it popped back up as soon as it started to freeze. That freezing released a little bit of energy, and then we've reached a plateau here, and it's starting to come down. So I'm going to stop, and that's what we need for our data. So we started at 50. I'm going to click our readout, and we can go and see that at this low point here we get a temperature. When we get up to the point here, this highest point after the dip, 43.13, and then it comes back down. We stopped it at 43.02. So that's the data that you have, and you have to choose among that curve on the basis of what we've created as introductory information, which of those temperatures you're going to use. Okay, so now we want to make this mixture. And so I'm going to take my thermometer out. I'm going to try to keep it from touching the side. That is not an easy task. And I want to keep my thermometer from losing any of the material off the tip, because that's part of the solvent. And I want to be able to put that back in and have it all be that same amount of mass that I measured at the beginning. So in this tube, I want to add my unknown component. And so that's going to go in my support. So I can let my tube sit here for a moment. I'm going to grab my smaller weighing boat. We need 0.8 grams of this. So I put my smaller weighing boat on here. Here's my unknown A. I hit tare, so I'm reading 0, and I want to get close to 0.8. So again, I can do my tapping, depends on if I get large chunks or not. I'm at 0.4, so that's half of what I want. So I know about how much more I need to put in. 0.65. That easy. I know I've got around 0.8. It's read 0.81. What matters is what we get on the analytical balance. So here at the analytical balance, I'm going to take my test tube with the lauric acid and the magnetic stirring bar, the support. That's going into balance. I'm going to hit my bar, 0. So the reading will be then whatever I add to it. I take it out of the balance. Notice I'm never putting any material inside the balance. And now because I didn't get any lauric acid spread along the side, I pretty much have everything down here in the bottom. That I'm going to melt. So let's weigh it again. Now this should be around 0.8. So I'm going to allow you to have a look And that's the number we need. That's the number we need to write down 0.8041. All right, that's how easy it is to make up our solution. We need to melt it. The melting part, I can put my temperature probe back in my tube. And now I can actually see what the temperature is when I have melted it. And now we have the same thing we have to do like before. Melt it down. I have a thermometer which tells me what the temperature is inside my... I don't want to stir it too much, I might splash some of this water. And I can get a quick check on the temperature. So right now it's reading above 60, that's good. Almost 80, and that's a little bit higher. I'm going to move it down to 3. That's plenty warm. My temperature is still 43, according to Logger Pro. And I have a little bit of my solute there. I'm going to put it on my stirrer to kind of get it stirred a little bit. So right now what we're doing is we're dissolving that solute in the solvent. The temperature is only 43, so I will need to get that warmed up. Although it looks like my reading is not being made. I mean, this has got to be warm enough. And so we have a little technical thing here that my thermometer's not updating to what's in here. So I'm sure it's warm. I'm going to hit collect. And I'm going to store the latest run. And it says 69, so we're plenty warm. So there goes my support. Putting this on my plate. I'm going to make sure my thermometer is in the center. We're at 66 degrees. It's warmer than it needs to be. And now we have to wait. I've clicked collect. It's going to wait until I cool my solution down below 50. If I put my test tube right in the center, then it's very quiet with the stir bar spinning away. So that keeps things nice and uniform inside. We're at 62. I'm going to stop the video and I'll start it again when we get close to 50. Alright, so we are now below 50 and a half. We're going to now start recording because it dropped below 50. So now we have our curve coming. And again, it's going to take about 2 minutes to get to this place where we will begin to see some freezing taking place. This is a freezing point depression, so we are adding a solute to our solution that depresses or lowers the freezing point. So this freezing point in the neighborhood of about 43 is a temperature which we're going to go past. It's going to go below that because we have this solute dissolved. A colligative property is where it doesn't matter what the solute is, it's just how many particles are there. This is a molecular solid, so it will not dissociate into multiple particles like a salt might. So all we care about is, like, if we know the number of moles, we then know the number of particles that are present in solution. The more particles, the more the freezing point depression. It's what we're seeing when we put things on the street for ice melter. We want to take that melting point, or freezing point for water, And we want to make that below the current temperature. Now when the temperature is as low as it was this morning, the ice melters aren't going to be functioning because we may not have added enough particles to lower that freezing point below our current temperature. But it does make it easier for it to melt when there's the presence of something like a little sunlight or something like that. So we have a very nice straight, beautiful straight line, much straighter than we had the first time. The straightness of the line isn't key. It's when we get to the point where we see some solid forming. And we are creeping up on, creeping down to 43. And this is where we saw freezing before. And I'll take the camera out, and we can take a little peek. We're below 43 where we actually froze last time, and now you can see that we still have a perfectly good clear liquid. There's no solid in there, and we are going to be watching this. We're well below. We are now 1.5 degrees below where we froze last time. We're looking again for this inflection point. We might see supercooling. There's always some times when we do not see supercooling, and I can't give any insight into what the difference is. We can get a freezing point either way. Supercooling does allow it a pretty easy way to specify where that happens. Okay, so we're now at 40.6 and still not an inflection point. We can come over and have a look at what's going on in our tube. Oh, I see solid forming. So there's our supercooling. It's now popping up, reaching a little maximum after the supercooling. And we've got a record of that. Come back over and look at what happens to our solution. You can see that it's rather cloudy and spinning around because there are crystals that have formed. And we certainly haven't frozen the whole thing. That would take a while. We just have a mixture of the solution and the crystals, and the crystals in there turn out to be pure lauric acid. The solute doesn't freeze out with it. So there's our picture. I'm going to put the camera back in the stand. We can have a look at that. All right, so what I see here is we had a maximum around here, and it's starting to go down again. A little bit of that, why it goes down, has been discussed in the introductory information. We have enough information because we've reached a maximum here and we're starting to decline. So I'm going to stop it. It took a little over 5 minutes to do that part of the curve. It took a little bit of time prior to that to get from 60s down to 50. So it's not a very long experiment. I'm going to click on my inspector here, and we can investigate a few things. Here we have our minimum where we had our supercooling, 40.16. Here's our highest temperature where we were responding to that supercooling. So you have that temperature, and we had dropped down below that by, let's see, 0.31, a few tenths by the time we got to the end. So those are the temperatures you need, and that is all the data that you need for this lab. So you're going to do some writing down of some observations, some measurements, and then guided through the calculation to find exactly, as precisely as possible, the lowering of the freezing point, which is a change in temperature. From there you can find a molality. From that molality you can deduce a molar mass. All right, well, best of wishes as you process your data and as you go through your quarantine. We pray that you will stay well and you'll be out and in person as soon as possible. Bye.